coming in. My name's Freddy Guime. You're here for the not so subtle prices of microservices. So it's a fun talk I have. I hope you guys have much fun listening to it. I had fun putting it together. For those who don't know me, my name is Freddy Guime. I'm one of the engineers at Expedia. I actually co-host a couple of podcasts. It's Java Pop House, Java Heap. Bob is one of my co-hosts over there. I'm also Java champion. Helped co-organize the Seattle Java user group, and essentially, what it really means is that I've been around the block and I have made a lot of mistakes. And the purpose of this particular session is, hopefully, you get to see a glimpse and say like, oh, wait a minute, I heard that Freddy, tried to do this and it didn't work out, and saved you at least a little bit amount of time. If I can save you a little bit amount of time, I consider this to be a successful talk. All right, so a little bit of what we're going to be talking about, right? I work inside of the Expedia group. If you ever search for flights, that's a very, very fine website over there. Essentially, when you're searching for flights, you're going to code that me and my team wrote, right? We architecture together. We make a lot of design decisions, and I was part of that. I'm part of that particular team. So what you see in front of you is, it's kind of a little bit kind of hard to see, but the important parts are essentially the little time bars. So this is essentially a time graph and essentially stock call of the different services that we have. At the very top, you get to see that is essentially what we consider the time to actually display you a flight search result. This is just a random flight search result that we did. Essentially, that took around 10 seconds. And where the second arrow is pointing is what is considered the actual time, where the quote-unquote the meaty part of doing a flight search takes. So essentially, we have to go out, get inventory from third-party providers. We actually have this problem where we do have an internal search engine that needs to go from quadrillion possible choices down to like the 30 or 40 that you see. So that part really just takes around, like on this particular search, it took around like 3 to 4 seconds. So why this took 9 seconds to show the results, but it took 4 seconds to only do the big part, right? So, we discovered this, we're running the traces, the first week we're looking like this, right? We're kind of confused, what's going on? But by the second week, we start looking like this. It's like, we don't get it, what is going on? We're doing everything right with microservice, everything, and by the third week we gave up. Like, it's just tough, right? So what I want to tell today is this story, we actually have, a success story, because after we did what we did, we discovered the mistakes that we made, and we sort of backtracked it on some of the decisions that we did. This is how the stack looks right now, right? Like, even though, again, it's not complete, what you see, like in the middle, those little things, they are not microservices code. They're just internal timings. It's still all one service, instead of being the multiple servers that I showed you before. And in this particular case, essentially, it took around 1.4 seconds to do the meaty part, and it just was 1.5, 1.6 to actually show it on the screen for the result. So we essentially eliminated all that overhead that we had when we were running our system to do the flight search. So that is the success story, and that's how we're going to walk through. Like, what were the decisions that we made that we realized that we did, the ones that were right, the ones that were wrong, and how do we get there? And this is the agenda. Essentially, what we're going to do is we first are going to go with the overt and hidden costs of microservices. We think that everything is free. Microservices, every time you create one, there is an actual cost to it. Both, and we'll go over the different kinds of costs there is. Also we go with the right reasons to microservice. Once you know what it costs you, there are legitimate reasons where, like, wait a minute, I really should microservice this. But in addition, I want to show you the wrong reasons. And we did all the wrong reasons at once. So, to try to give you a little bit of inoculation, you get to see, oh, these are the wrong reasons, then you start thinking about it a little bit. It's like, oh, I remember this. Maybe we should take a look at it a little bit deeper. And lastly, if we see that my microservice is not the solution, or adding a new microservice is not the solution, well, what can you do instead, right? So in this talk, I sort of started with this idea of like, oh, it's Superman versus Batman, right? And I don't want to start, like Marvel versus DC wars. This is just the superheroes that I happen to like pick up because they're easy to identify, right? And Superman is the do-gooder, right? Like he is the nicest guy. He shows up, he beats the bad guys, but also goes to like children's birthday parties. Like it's the guy you want to have all the time around, right? Batman rules by fear, right? Like he is a superhero. You wouldn't want to have at a kid's party, but if they're in trouble, you will want to actually, have Batman next to you, right? And I want you to think about microservices, not as the Superman of the picture, where you just want to throw microservices at everything, but more of like, gosh, Batman is tough. He is, I'm just gonna use Batman if I really need to call him up, right? So the first part is overt and hidden cost of microservices. That is Donald Rumsfeld, and he has this famous saying or infamous saying, depending on how you think, that he did it like whatever it was 8 years, 10 years ago. No knows and no knows. And what he was trying to, even though he sounds funny, he was really trying to get to a serious matter, that there are certain things that we understand that is going to cost us something, but there are other things that we have no idea what they are and what they cost. And I think one of the problems that we got into was that we never realized how much it costs to add microservices to our organization, right? So the non-costs for doing a microservice are very well known. You have hosting, because all the cloud providers will charge you happily for whatever you want to do, right? We also have network costs. You cannot infinitely download from S3 or the other buckets. They'll charge you for like how much you're moving, how many bits you're moving. Lastly, you actually have operational costs, which is like your licensing. You may have like software that does a scanning for vulnerabilities, and they have a per service rate, or you have your Jenkins pipeline that can do this much, and then you need to actually add new services to help you you deploy and use the pipeline with your new microservices. So these are the known things, but I want today to look at what is usually overlooked, right? Every time you create a new microservice, you, depending on how you slice it, you might be running into complecting. And complecting is a word that was essentially, it's an old word, it means to intertwine, but it was coined a lot, or it started being used in our industry around the time that the Phoenix Project book was done. This book talks about essentially how to create, or how to essentially elevate a traditional company to be more DevOps, more agile, and all these things, and the things that you have to do. And one of the things that they say that the problem why things took a lot of time to do is because when you split your services, sometimes you split it in a way that you really didn't split it, but you essentially tied it up. Just a quick question, by show of hands, who has a service that when they deploy, they need to coordinate with somebody else to deploy something else? That's complecting. So what that means is, even though you try to split the things up, now suddenly the price that you pay is coordination. It's like, oh gosh, I have an emergency release to do today, and you're like, oh no, the other guy says like, no, we are running an A/B test. We cannot touch anything until next week. And then you're trying to negotiate, and it's meetings on meetings on, can we release it? Can we patch it, right? So that is one of the hidden costs. Every time you add up new microservices, you run at a high risk of completing things. Now, the second part is about domain complexity. Now, domain complexity, I can talk for an hour about domain complexity, but there's this kit that makes it much more fun and gets to the point much, much quicker than I can. So I'm going to spend the next 2 minutes for us to watch a video together.
One feature. Why is it taking 3 years to develop? Look, it's not that simple. All right, I have priorities, my team has deadlines.
I'm still not understanding this. Why is it so hard to display the birthday date on the settings page? Why can't we get this done this quarter?
Look, I'm sorry, we've been over this. It's the design of our back end. For example, the Bingo service. See, Bingo knows everyone's name though, so we get the user's ID out of there. And for Bingo, we can call Papaya and MBS to get that user ID and turn it into a user session token. We can validate those with Omna, and then, once we have that, we can finally pull the user's info down from Raccoon.
Yeah, but Raccoon and the Raccoon team basically did.
No, Raccoon isn't guaranteed to have that info. Before we do this, we have to go to Wingman, do a query to see if the user is willing to take it to the next level, or if they're just playing the field. Now, Wingman is cool, but he doesn't store any user info himself. He has to reach out to other user info provider services, like RGS, Barbie-Doll, Ringo2, BLS. But how does it know what all the user provider services are? Well, for that, it has to go to Galactic, all-knowing user service provider aggregator. And while Galactus has omniscient knowledge of all current user info providers, it doesn't have future sight or knowledge of past user info providers, so it expects a timer. To get all the current user info providers, we need to pass a time range with the current time and a time representing the end of the universe, which we get from EKS, our entry chaos service. EKS is being deprecated at the end of the month for Omegastar, but Omegastar still doesn't support ISO timestamps like they said they would a month ago, so until Omegastar we're blocked. We can't get signed up for our use case, we can't use EKS, there's nothing we can do. So Galactus won't be able to find our new birthday boy provider, which means Wingman won't know how to talk to anybody, which means I won't be able to find true love and I'll die alone. I'll die alone, without ever knowing love, without ever knowing it's my birthday. We're blocked, okay? We're blocked, you sad, pathetic little product manager. You think you know what our users want? You know nothing of my pain, of Galactus's pain. You think you know what it takes to tell the user it's their birthday? You know nothing. Delivering this feature goes against everything I know to be right and true, and I will sooner lay you into this barren earth than entertain your folly for a moment longer.
Alright, so clearly this is a blocker. No problem, push this out another 2 to 3 years or so. Learned a lot today, love Galactus. But we'll talk next week about adding middle names to the profile. Awesome, sounds good. Take care.
One thing.
By show of hands, who identifies with this? Full house, right? And it hurts. And it hurts because it's close, right? Like you can almost even like if you didn't, you can almost see it like it could happen. Yeah, that we do have different providers for names. Like so, but the thing is, it does drive to a point where it's what we call domain complexity, right? Like it's hard to reason on a system that has all these units of separation, right? Like just think about it. Like if you have a bug on a system like this, right? You start from the very top because that's what we always do. We go to the UI layer, trying to figure out did we see the wrong thing going down, and suddenly you go like, okay, oh, there was a 500, right? I returned on one of the services. You go to the services, I found the service. You go to the backend service, you looked at it, and it was like, oh, a circuit breaker tripped. And you're like, why did a circuit breaker trip? And then you have to follow that, oh, it was a call to a database that was timing out on the back end. And then you're like following the call, and then suddenly, why is the call timing out? And suddenly somebody else deploy a different service that was doing a thundering her problem, meaning that we're just overwhelming the database when they're being deployed, and that caused the thing. What I told you right now is a real case. It took like 3 days of looking at logs and trying to reconstruct what happened. And that is sort of like the price that we pay every time that we decide that, you know, like, oh, we have a new microservices. It's harder to debug. You know, same with adding a feature. If the feature that you're trying to add, you know, happens to be on a service, that's great. But most of the time when we split microservices, sometimes a feature has to be implemented piecemeal on these different microservices. Sometimes you're wondering, is this the right place that I have to implement it? Am I able to actually do this on a sprint, or do I have to coordinate with 5 teams to bring a feature, right? So you know, the thing is that even if you're new, or even if you're bringing somebody new, or if you've been at this for a long time, it's very hard to understand. Simpler systems are easier to debug and are easier to like add features to, and that is another part of the price, you know, one of the hidden costs of doing microservices, right? Like, the next one is about uptime. We have a service. It has 99% uptime, right? Guess what happens when I have a second service that also have 99% uptime? Well, let's say that these two services are tied in together, meaning if one service doesn't work, the second service cannot receive, like the whole system goes down. Doesn't matter which service. You know, by show of hands, who thinks that the uptime of the whole system is 99%? What about 98%? All right, so we can skip those slides. So the idea is that uptime is the multiplication of all the different uptimes that you have for each service, right? So in this particular case, you're right, 0.99 times 0.99 is 98%. That's your essentially guaranteed uptime if your individual service were 99%. You add another one of those services and the thing gets getting worse. Sometimes you don't realize, like when you're looking at it, it's like, why the thing is always flaky, right? And when you realize how many microservices you have and how many of these are codependent on each other because they're complected, then you realize, oh my gosh, any one of these can go down and takes everything down, therefore making our uptime for the whole thing lower, right? So we have that problem or we have that challenge in one of our services, right? Like, we actually have a baggage fee service. We actually have a service that its only mission was to figure out how much you're going to pay if you decided to add a bag to your flight, right? And the thing that happened is, like, when that thing went down, everything went down. And one of the questions then that some of the people will be asking, but Freddy, okay, let's say that we don't have that baggage fee service. Let's say that we actually roll that baggage fee service into one of other regular services, right? Like, wouldn't you still have the same problem? Because it is still the same code at some point in time, right? And it is true. Like if there is a bug on code that you write and you deploy it, then yeah, that bug will cause the thing to go down. But first of all, we know how to deal with this. We, as software developers, we have known, like, the blue-green deployments, rapid rollbacks, all these kind of things that can protect us for code errors, right? If we manage to make it to production. But a grand majority of things that make our web services go down, or at least a good portions of it, is not necessarily code, but it's operational details. Somebody misentered a DNS entry. The CI/CD pipeline did, bungle up when it was deploying an instance. Somebody didn't right-size the step scaling for the new service, causing, essentially scaling up to 300 instances and then going to the database. Like, all these things, or this operational complexity of a web service, are things that you don't have to worry about if you don't create a web service, right? So the next hidden cost, or the one that is not so obvious, is the infinite bandwidth, right? And this is Peter Dush has this sort of like this distribution computer fallacies. They're all real, but right now we're just concentrating on this one for this talk. Like, the network is reliable, latency is 0, we have infinite bandwidth, and transport cost is 0. And that was sort of like our Achilles heel for what we have, right? Now, in our service stack, we use XML a lot, right? XML, the airline industry grew up out of Edifact. They are on XML. They might embrace JSON sometimes in the next 20 years, right? So we have to deal with that. But the XML payloads that we have to, like we say, we were dealing with quadrillion, then we built to 1 million, then, sort of like 60 to 100,000 possible choices. We need to encode, decode, transmit these things, right? And when our microservices communicated with each other, they communicated over XML. It took around 1 second to actually encode the thing, and it was around like 1 megabyte of on-the-wire size. And we had to do that per request, right? Like, if you have to process XML, you know that you have to essentially you go from objects to essentially a formatted string, and then when you're decoding it is the opposite, right? You get the formatted string back to getting the internal model representation, or at least the XML objects that you generated, right? And this is expensive. When we were doing it, we were CPU bound. That 1 second, it was entirely burning one CPU core, right? And this sort of was like the structure of our flights microservice architecture, where we had, all these different services communicating, sending that 1 megabyte payload back and forth. You get like 1, 2, 3, 4, 5, 6, around like 6 to 7 of these messages were being passed around to try to get those results. Right? And because the transport cost is not zero and bandwidth is not infinite, this actually takes time. It takes both CPU time because you're burning the cores, and it takes network time because you're pushing those bytes on the wire. Right? And at this point in time, she's very mean. She says, obviously you made a mistake using XML. Right? And now we're going to the interactive portion of this talk. Right? By show of hands, who is like XML gurus, masters? You dream XLST, you know how to do transformations. All right. So if you're an XML guru, like the very first thing that you're going to say is like, oh my gosh, you're using XML? You should have used fast info set, right? And the fast info set is essentially binary XML. It's not quite compressed, but there is a lot of it does have a dictionary to be able to sort of make the payload smaller. Which, what I'm talking about right now is actually each step that we did. We actually first went from XML to fast info set. Still not good enough. It helped us a little bit, but still not good enough. So now, by show of hands, who is familiar with XML, but when you started your software development career, you were more on the REST endpoint stuff and sort of like HTTP web services, right? All right, so that's almost like I'm gonna say I am the Asian generation. There's a new generation coming out, right? If I were to ask, it's like this generation, like that generation, oh, I made a mistake. Instead of XML, you should have used. Let's see. I'll ask the audience, oh gosh, Freddy, instead of XMLs, you should have used JSON. There we go, right? And that is exactly where that was the next thing we did, right? Like JSON, it is a little bit more concise than XML, but not quite. It's still a text format, right? And that didn't quite work well. It's still a big payload. And it's not 1 meg now. It's 500K. It's smaller. But then of course you keep asking, and let's see. For the people that answer JSON, what would be even better than JSON? Okay, you jumped the line. That is. We will get to that one. But yeah, the next one is BSON, which is the binary representation of JSON. It's a little bit more concrete, not human readable. But for the people and who said Protobuf? Of course he did, because he helped make Protobuf popular out of Google, right? I was going to ask, who knew? Who has to work with very hard problems they have have to transmit a lot of content in very little time, and the people that really concentrate on this, they come with solutions like that, completely binary encoding that allows you to be very efficient on the wire. So when you deal with Protobufs, which is where we end up doing for the parts that we needed to do, it becomes very, very concise. JSON is great for humans. Protobuf is amazing for machines. Takes little time to encode, takes little time to decode. Usually in Protobufs, you have the advantage that you have generators for reading off the wire that are not reflection-based, that are not property scanning-based. They just say, oh, this bit goes into this field, this bit goes into this field, which makes it the most efficient way to communicate, right? I'm going to borrow one of the comments that Gil said. Gil Tanner, who runs who works at Azul. He has this thing where he says the internet is running with the debug flag on. And what he means is we tend to love JSON and stuff, and actually it does work, right? JSON is good. But for the performance part, machines don't care about the text. Machine just cares about the bits. So sometimes we tend to overlook these type of solutions like Protobufs that can help us get there and be more efficient on the wire, right? Now I'm gonna see if we can get this trick question. And Alex, because Alex breaks the curve, you cannot answer this one just yet. The fastest way to optimize performance is, any volunteers? Okay, Todd is right. The fastest way to optimize something for performance is to just not do it, right? It is crazy because it is a simple concept, but sometimes we forget. It's like, no, with microservices, we split these things up, and now we're suffering because we are encoding and decoding. How can we not encode and decode as much? And the answer is, don't split it. Keep it together, right? Now, walking through these things, there are right reasons to actually microservice. I don't want to say like, oh gosh, all microservices is back. Let's go back to the 1960s. Forget that REST happened. No, there are real reasons why microservices are a good choice. The first one is asymmetric scaling. And what is a fancy way of saying, right? Like when you have a service that is doing these 5 things, and usually the profiling of that service is like, yeah, we're spending some time on these things and it's fine. But then you add a new module, right? Like you decided I'm going to add some machine learning to my service. It's going to concentrate on these things. And suddenly you realize that that machine learning module that you added suddenly makes your service extremely slow. You have to scale out. You have to have, like, before you used to have only 5 instances. Now you need to have 200. And everybody's wondering what happened. It's like, oh, we added the machine learning. Now we need to scale everything up. But the reality is you didn't need to scale everything up. You just have something that was very heavy that was dominating your particular microservice. The right solution there, it is to split it up. Because then you have other choices. You can say, you know what? For the machine learning cluster that I'm going to create, I'm going to make it compute ready, or we're going to be compute bound. I'm going to use different kinds of instances that are optimized to be very efficient on this. And for your general service, you still keep it at your general compute cost, right? Like you get your 2XL, your 1XL, or your ECS, and your Docker containers, and that works fine. So this is one of the reasons to split a microservice, when you have sort of like parts of the stuff don't scale linearly. The second one is mix of tech. Unless you're in a startup that was funded yesterday, most of us have to work with code that has been written before. And some of these might not be on the language of our choice, right? So you have something that, there might be some Python and ML. You may still have an AS400 running around. There's .NET code that somebody thought it was a good idea. There's a Java end with Spring MVC. And sometimes, instead of saying, like, I need to group these together, it's okay to keep them apart as microservices. Either you add a layer on top of it, or you implement a particular endpoint because you don't want to move or migrate everything to one platform. That's not necessary. We learn how to create different ways of agreeing with each other and communicate it across languages. So this is another good reason for splitting microservices. The third one is there is a legitimate divide and conquer strategy. Fun fact, I was looking for a king type of picture. This came up, and it looks like Lord Farquaad from Shrek. The crazy part is I think that statue is real. Somewhere there's a Lord Farquaad statue out there. But, coming back, right, I digress. Like, the idea is that not all microservices are bad, right? Like there is the advantage of separating certain concerns if it does allow you to evolve them independent of others. There is interdependency, because if your service didn't talk to anyone else, why does it exist, right? It gets very philosophical. It's like if the service doesn't communicate, does it really run, right? So you will talk to other services, but the idea is that you don't have to coordinate, right? Like you can evolve these things. You made a hard contract. You say, this is my country that we're going to talk to each other, but then the rest, the team can just go and build features, figure it out, refactor things, and not depend on anyone else. That is the good kind of splitting, right? So those are like the major good reasons. There are more nuance on them. There's probably other smaller things that might make a good fit for saying, like, I should break it on microservices, but those 3 are the best. Now, the thing that I want you is to inoculate you when you hear these other ones, that this might not be the best reasons to actually squeeze it. The wrong reasons to do microservice. And just as fully transparent, we did all of them. Like, when we implemented things, we committed all these sins, right? That is me when I have to open a new project within our 1,000 microservices, when I open a new code base that I haven't seen before. Because you're like, how is it going to be? Is it going to be good? Is it going to be bad? Right? And you're like, who did this? This is like Java 6. And you're trying to figure things out, right? Like, and the first thing is like, a lot of people will come in and say like, look, that microservices is really a dumpster on fire. Nobody wants to touch it. The last person the two last commits that happened in there, one of them was to create a global share state object because somebody needed to implement a feature and they didn't want to deal with the camel routing that was internal. And then the second one was like, oh, since there's a global state object, I'm going to put more information so for a completely unrelated feature on that particular global state object, and nobody wants to touch anything because if you touch it, it breaks, right? Who has those kinds of code bases? Come on, don't be shy. And that's the thing, right? So I did have, like, what I just told were real 2 cases that has happened. Like, we have code bases that people didn't want to touch. But the right approach to it is us as leaders, right? We have to figure out, first of all, how did it happen, right? Is it a matter of, like, nobody was paying attention and people were just committing to it and nobody was there to, like, correct it? That was like that. And sometimes that's intentional. Like, sometimes you decide, make a decision that's like, I know that this is not the right way to do things, but we're going to allow it because we have business pressures and we have to deliver certain things, and that's fine. But then own the error, right? Like, it's like, we deliberately decided that we're going to let tech debt accumulate. Now, the risk of accumulating enough tech debt gets to a point where now you have, like again, it's like compounding interest, right? If the code base gets very, very bad, sometimes you cannot rescue it. Sometimes it's like, yep, it's completely broken. Now we just need to figure out how we're going to rewrite it, and that should be the choice. Like, you know, not deciding I'm just going to keep avoiding the problem because I just keep adding more tech debt, and you're paying the other side of the hidden cost of microservices without having the real value of paying for that, right? So the right approach to do it is if you do have to go to code base, you have to do what the Pragmatic Programmer book, which is a great book in there, tells you is almost like the People Scout rule. When they go camp somewhere, they always try to leave it a little bit better than what they found it. So if you have to go to a code base that's really very ugly, right, but it's still not beyond repair, you try to do something. Take out the share state, make it individual, make it part of the message. Take out something else that it might not be exactly your feature, just tangential to it. But you know, if you keep doing this more and over, you essentially make that code base better to the point where, okay, we can work with it better, right? But these are deliberate decisions that have to be made. Saying, we know it's bad, we're going to fix it. Everybody who commits here, dedicate 10% of your time to actually get it going, right? The flip side of that coin is Greenfield Development. Now, how many times, I get engineers coming in and it's like, gosh, we can create a new web service and this time it's going to be perfect and we're going to do everything, right? Like, we're going to do Java 17, it's going to have gRPC, I'm going to put all these dependable things in the top, we're not going to have any problems at all and it's going to be perfect forever. I've heard that so many times. And the interesting part is it comes from a good place. It's like, I want to do something new. I want to make it sure that it's great. But the reality is that we tend not to write a lot of code. We tend to maintain a lot of code, right? So the right approach there is you cannot just say like, I want to do Greenfield because I want to do Greenfield. It's like you have to understand that the real value is going to the code base that we have and maintaining it and making it better. Not trying to just split up and create my own little project because, and I understand, like, even code that I wrote 1 year ago, I just have to go to the project that I just created 2 years ago. And I opened it up and I looked at it and I'm like, was I doing this after I went to the speaker dinner at Devnexus? Like, because it's all like weird and like I use patterns when I shouldn't use them. And to be honest, that's how we all feel. Every time we are the the worst critics for our own code. But that is a good sign. If an engineer comes to me and says, my code's still perfect from a year ago, it just means that you have not learned anything in a year. So it's part of it is being comfortable knowing that what you wrote a year ago or 6 months ago is probably not going to be what you will write today. And the difference between the difference I always see between the juniors and the seniors is that a junior developer is like thinking like, I'm going to think for the future. I'm going to try to use these 20 patterns to make sure that it'll survive forever. And the senior is like, I am dumb. I'm just going to do the next 6 months, and then after 6 months, I know whatever mistakes I made, I'm just going to refactor them out. Like, what you're trying to give, what I see is like, the more experienced the developer is, the more license they give themselves to say, I am allowed to change my mind, and I'm allowed to change my code base, so it reflects the realities of the business today. And once people start getting sort of like that comfortable, that's when you start seeing these beautiful code bases that don't age or don't deprecate the way that somebody who they don't degenerate in dumpster fires, right? Now the third reason is the reason why I hate the micro and microservices, because without any context, anyone can take it to mean whatever they want. Like take this for example, and I'm gonna actually name real services or the names of the real services that we use. We have the Goldstream search service, which is top of the funnel. We have the Air Offer service, which is in charge of creating offers. We have the Air Pricing service, which is in charge of figuring out the pricing for that offer. We then have the Supply Orchestrator services, which is in charge of orchestrating the supply stuff, right? Like going to the third-party vendors and stuff. And I comment this and looked at it, and it's like, that's what it should be. We have a service that just searches for flights. If you contribute to searching for flights, you go in here. You're not doing searching for flights, go away. But like everything that searches for flights should be on a service. That is the boundary. That is the micro in the particular environment that I am in, right? So, what to do, right? I'm trying to say we have all these things, and I'm saying like microservices. I'm not saying necessarily they're bad, but they're costly, right? And this is one of those things that we tend to believe that computer science was born in 1990s, right? With REST and web services. But the reality is that even though we're young as a discipline, right? Like we cannot compare it to math or anything that has been running for 5,000 years. We do have experience on actually working with code bases, right? And one of them is the concept of the modular monolith, where your code base is one, but you actually have modules in there, right? Well, one of the things that you don't want is that's what I have designed in there is that you don't want any ball of mod, which is sort of like the anti-pattern forget his name, but one of the anti-patterns that is called, like where you just have like spaghetti code all over the place, right? But the advantage of a modular monolith is that you don't need to encode and encode anything. Everything is local. You don't have to split things that don't need to be splitting to a different service. The one thing is that you do have to be disciplined on keeping things decoupled. You cannot have somebody just creating a pull request with a global share state, and suddenly two things that were unrelated now are actually deeply coupled, right? So for what we did was we decided, this is too much. We went too micro on the micros and decided all these concerns are just one service, right? Then we decided to then, for the part that we said, okay, the paths or the part on the right is saying, like, for example, that we need to actually contact our third-party providers, and they have like different kinds of contracts and different kinds of scalability concerns. We're going to still keep those separate, but for communicating with them, we're just switching to Proto, right? Like make it as much efficient on the wire as possible, right? So in closing, the one thing, if there's one thing of this talk that you remember, is that our job is always about trade-offs. Every time you make a decision, always see what are the pros, what are the cons, and be extremely, extremely careful. Like if it only seems that there is only an upside, That's when I get the most afraid, because that's when I know that I have a point, a blind spot that I'm not seeing. What am I paying for? So remember that even creating a microservices has trade-offs, right? Lastly, as a PSA from my company, we are hiring. We're hiring everything, everywhere. So that's the reason why they let me take off for this 3 or 4 days. Is, show you that we are actually there. If you want to work with me, if you like the talk and you want to say, hey, that Freddy guy seems kind of interesting to work with, these are the things. Just see me after the presentation. We can always talk. And that's it. Thank you for listening. So I now open it up. I don't know how much time we have. Oh yeah, we have some time. Questions? All right. All right. So the question was, do you have any guidelines for how do you come with microservices or macroservices? Like how do you find the boundaries? Is that what the question is? All right. Like the way I'll say is it's easy to start. Like if it's something that you're starting or you're appreciating, it's easy to start bigger and then split up smaller. It was way more difficult to do what we did, which is, we already decided we need to split these things without even considering them and then group them together. So, it's almost like let the system push you, right? Like if you have a choice of having one thing that is somewhat you consider somewhat big or you're scared because it looks big, start there and then make it such that you can split it up, right? You start with Modular Monolith and then it's like, no, this really has all the smells. Our two teams are putting in, they never interact with each other, but they have to be on the same code base. It's sort of like, okay, that's almost like a sign that this could be split up, right? Like there's probably somebody who is smarter than me that put a very big list, but the way I always design is like, start with the easier part of the design first and let the design push you to the right decision, right? If I start big, the design will tell you suddenly when you're running it, it's like, oh, we need to split this part, But do it after you run it and after you get the measurement back, right? If you try to do it before, then you get what we had, which is people thought, oh, simple concern, it should be smaller and smaller. Right? Any other questions? Right. So the question is, essentially, well, you had 5 microservices before with 5 quote-unquote different teams working on it, and now suddenly you have one big service with those 5 teams now working on that one service. What are the consequences? The beauty of it is like if you really split your microservices as badly as we did, your 5 teams were already doing the same thing. Like I needed to go to this code base first, then I needed to go to the next service code base, then I needed to go to the third one. So now they just have one project. They're actually 10 times more productive because of that. But yeah, it happened because we split it wrong and we decided that consolidating was the right thing. But when we did that, then everybody was like, oh my gosh, everything is here. I don't have to go chase whatever that bit is everywhere. Because changing one, like imagine adding a field on that messaging structure, that means modifying 5 things. Now they don't need to modify one. People actually can work on other things besides changing fields. So, any other questions? Huh? So our story. So the question is, what was better than JSON but not Protobuffs, right? So our was XML, fast info set, JSON, then BSON, BSON, which is binary JSON, and then of course there's Protobuffs, and then I'm gonna poke Alex and say like maybe Cryo, but protocol buffers. Google project, the guy over there actually helped publish it, so if you have any questions, you'll know all the answers. Also, he has set feature requests. I'm kidding. All right, any other questions? All right. If that's it, thank you so much. I know that people are still trickling in to I'll go in for the raffle, but that's all there is. Thanks.